Hi there, sitting next to me here is a Texas Instrument TI990 single board computer. It's actually the board in the back here that you can't see very well. There's actually two boards here. The one in the front is a board that I designed myself to go along with it. The one in the back is the TM990 single board computer. I will yank them out of here in a moment and we'll talk a little bit more about them in detail. But for now, that's what we got. It's mounted in a 4-slot backplane. You can actually run the board by itself because it is a single board computer. You could just take a connector, stick it on the bottom, and plug your board in and power it with power and have yourself a little computer. But the 4-slot backplane makes this a lot more convenient, and you have a couple more slots in case you want to plug something more interesting into it. The manual actually tells you how to make this little test harness here. It even tells you to right top and turn over on the connector, like I've done. Okay, here is the CPU board. Now, all of this started when I spotted a complete TM990 computer on eBay that had a card cage, it had a CPU board, and some peripheral boards. I didn't buy it because it was too much money and I didn't know anything about it, but it kind of stuck in my head until eventually I saw this come up. One of these boards here that was just the CPU board. This is a TM990/101M, which is slightly newer than some of the other ones. There's also some TM990-100s out there, which might be a little bit older. I can't say exactly why I picked this generation other than I was just looking through eBay listings and this is the one I ended up. You've got your TMS9900 CPU, this great big IC here, the 16-bit CPU. TMS9900, same chip as the TI-99 computer. You've got some support chips like this TMS9901. You've got RAM here. I think this thing has 2 kilobytes of RAM, so you've got 8 RAM chips there. So this is a 16-bit computer, so I'm not refreshing my memory on exactly what the configuration of this is, but somehow you get 16 bits of memory out of those 8 chips. Maybe they're 4 bits wide or something. You have over here your ROMs. There's sockets for 4 EEPROMs. I yanked if there were EEPROMs on the board, I don't even remember because it's a while ago, but I would have yanked them and put my own here and put the monitor. 16-bit computer, of course you're going to need 2 EEPROMs, a high and a low, or an even and an odd, or whatever you want to call them. Got 2 serial ports up here, and they have these 2 serial controller chips. Now this is kind of strange here because usually you think of a UART. It's like a great big IC. Here you've just got these little ones, these 9902s, and I think the way it can be such a small chip, at least one of the reasons, is because it has this weird 1-bit I/O bus between the CPU and some of the peripherals. So a normal UART, you'd have to have an 8-bit bus. It's got a little 1-bit bus. Anyway, the smallest serial driver chips I've ever seen. You've got some dip switches to configure some stuff. There's a lot of jumpers around. You got to find the manual, figure out how to set all your jumpers. And then over here you've got a parallel I/O port of some sort. I haven't really looked into how that one works. And then you've got your reset switch, this kind of cool paddle reset switch thing over here. Looking at the back, not much to see. Here on the back, it's just, average PC board. Initially, I did actually get this thing going via serial from the monitors on here. Now, since then, I have turned the monitors off and switched to my own memory board. Let's take a look at that. Okay, and here is the companion board that I designed to go along with the TM990 to give it some additional capabilities. Now, I based a lot of this on some of Stuart Connor's designs that he had online, so thank you, Stuart, for the inspiration. And what we have here is a multi-function board that has got ROM, it's got RAM, it's got IDE, it's got video, and it's got a couple of Intel-style multi-module slots. So let's go through these one at a time. So usually I do schematics, but I'm not going to page through a bunch of schematics that really aren't that interesting. They're really just like memory addressing and such. You've got your ROMs over here. I'm using a couple flash devices, but I think the way I've done this, you can use flash devices, you can use ROMs, EEPROMs, whatever you want to put in there. It supports a variety of different ones. These are ZIF sockets, so you can flip this lever off and pop these things in and out easily. Now, the amount of ROM I have is more than the address space supported by the computer. So what you have over here is a bank selector for the ROMs, and there's 4 switches, so you can do 16 different segments of this ROM that you could map into the ROM space. So this lets you have several different programs, and you can easily flip a dip switch. So like in one bank, I put the original Texas Instruments monitor. In another bank, I've got Stewart's new monitor, as well as the basic. Another bank, I've got fourth, and you just flip your switches and pick which one you want. Better than popping chips in and out. Now, 16-bit computer, so you need, your high and your low, or your even and your odd, whatever you want to call it. You need two 8-bit, ROM devices to get your 16-bit. Then you've got RAM, and again, we've got two devices here. These are 62,256, which, if my memory serves, those are 32K devices, so you've got 64 kilobytes of RAM. 64K of RAM, and we're mapping 64K of ROM. Now, to fit those into a 64K address space, I have these switches over here that let you switch in 4K increments, whether a page comes from ROM or from RAM. And we've got a set of switches for the ROMs and a set of switches for the RAM. So you can, if you look at this closely, you'll see that it looks like I put the ROM at the beginning of the address space, and then over here I put the RAM at the end of the address space. So probably, it's been about 3 months since I designed this thing, but probably what I've mapped this to is 32K of ROM and 32K of RAM. Now down here you've got a couple of LED displays. Again, this was Stuart's idea from his page, and these things will light up when the CPU is accessing a particular page of memory. So you can kind of see where the CPU is accessing around in RAM. Next up, we have an IDE device. So here's an IDE connector, as well as a compact flash socket. The compact flash is wired in parallel with the IDE connector. Somewhere around here, I don't know exactly where, probably down here. So you've got an 8-bit buffer that goes along with the compact flash IDE. That's just mapped into normal address space, so we can read and write that. Then over here, we have a Tang Nano. Now these Tang Nanos are all the rage right now because people are using them to replace TMS9900. Popular video processors are from the MSX and similar computers. People are replacing them with these Tang Nanos, and you get an HDMI port right there on it. This is an FPGA type device. You can buy these cheap on AliExpress, you program it, you plop it in here, and then to the computer, it just looks like the vintage video controller device, but of course it's running an FPGA and it's giving you HDMI output. So you don't have to fuss around with all that composite video and ghosting and finding yourself an old monitor. You can hook this up to modern video. Finally, the last thing on here are these two sockets. These are Intel multi-module sockets. So if you watched my recent video on the IPDS computer that I restored, in that one it had some multi-module sockets for bubble memory, as well as I built like a speech synthesizer and a sound card to go with it. And that is what these are for, because these multi-modules, I'm going to start leveraging these for all of my projects, because then I can just build the module once, put a socket on the main board, and then I can port the modules around. So I've got a couple of these modules. This one here is a sound card based on the AY38910, and this one here is a speech synthesizer based on the SPO256. Now you can see these things are, there's a little bit of bodging going on here. I actually wired this up so that the audio out can come out here and kind of hook up to the audio input here on this Tang Nano, and you can get the audio output over HDMI, so that's why you see a little yellow bodge wire. And I stuck these speakers on there in case you don't want to use that, so that's why you've got the red and the black. But these are my latest design for the multi-module. So, and like I say, the nice thing about this, if you want to plug something else in there, like there's an ISBX 218 floppy controller you could put in there. There's the ISBX 251 bubble memory, you could put it in there. There's numeric coprocessors, there's parallel I/O, there's serial I/O, there's A to Ds, D to As. There's, if you look at the catalog from the late 70s, early 80s, there's all kinds of multi-modules that fit this standard form factor. So start building my boards with those, and I'll be able to plop stuff in there like that. Okay, so that is the companion board. And like I say, the important thing with this is that you can take the main board and you can add all this extra ROM and all this extra RAM and do some interesting things with it. Finally, we've got the backplane. Now, I bought this backplane from Stuart out of the UK, I think is where he's based. Just the green bare PC board in here. It's a nice thick PC board. Then I bought the connectors off of AliExpress. You can get those kind of cheaply. They're the same as S100 connectors. And then I 3D printed these guides that I stuck on the side. And then I mounted it all to a chunk of plywood. In retrospect, it would have been nice had I just bought that nice backplane that I saw on eBay at the start of all this. But no, I kind of went around it this way, which is a little bit more interesting because I got to 3D print, do some 3D print designing. And you know, you can take and you can plug your you know, boards in like so. And it'll hold up to 4 of them. So even if you just want to do the CPU board by itself, it's one slot. You know, if you want to add memory board, something like that, you've got another slot. If you look, people use these TM990 modules for industrial computing. So if you look on eBay, you'll see all kinds of TM990 style boards. So you might find something interesting to plug into some of these. There's the EEPROM programmer board, there's bubble memory board. You probably can't see it, but there's a cable here that comes out. I probably wired it. I can't even tell exactly where I wired it, but it wires down somewhere on the underside, and that is where the power comes in. And then Stuart gave us a spot here to put some LEDs so that we can look and see the status of whether the power is being applied for your +5, your +12, and your -12. Anyhow, that's easy enough. So let's assemble it here. Like so. Look at this. Like so. And then we can go power this thing up and try it out. Okay, time for a quick demo. So we've got everything hooked up here. I do have serial hooked up here. The serial cable, it comes out, it snakes around back here. You can't see it back there, but there is my propeller-based VGA serial dumb terminal, which is hooked up to the HDMI monitor. And then down here is a keyboard. So let me hit the reset button. And right now the ROM that I have in here is for the TIBUG monitor, which is what this board would have come from. Now TIBUG doesn't do anything until you hit return key a few times. So let me hit it. There we go. TIBUG revision A. And I don't know that there's any help in this thing. Let me hit question mark. That doesn't do anything. H. Well, H is some kind of command, but who knows? H1, H2, I don't even know what that does. If you read the manual on TIBUG, would tell you a little bit more about it, but let's do, I know a few of the commands like memory dump 0000, comma 0100. That should dump out some memory. And there we go. There's some stuff that's in memory. It is a 16-bit computer, so you're seeing 16-bit values output here. So TIBUG is not very convenient at all. So let me show you something else. I'm going to show you Stuart Connor's monitor. So Stuart is a great guy who does a lot of these TM990 projects. And he developed a monitor for this and ported some versions of BASIC around. So let me switch the ROM. Let's hit this again. And now we're in TIBUG here by Stuart Connor. So we can hit question mark. Now we have, we have a nice menu here that tells us all of the various things we can do. We've got our memory inspect and change, and there's some better stuff, like there's a hex ASCII one. Let's try this. 00000100. There you go. That's a little bit more of a convenient output there. And one of the things it can do is it can run a ROM program. So there's this P command, run the program that's at 2000. So let me hit P, and here we go. Here is the basic, I believe. Yeah, this Stuart ported this, and you can see here we're looking at TMS9900 Project Basic. So we can write a little basic program for I equals 1 to 10, print, let's do Scott was here, 30 next I. Let me tab that up there. You can get a good look at it. Run it. There you go. Pretty simple. Your typical basic language. Now, Stuart did implement some commands in this basic to use the built-in IDE. So these are extensions commands. So they start with star. So star dir that lists the files on it. You can see I've got a bunch of Forth stuff there. Let's load this Scott program, which prints Scott was here. Now I think that's the very same program I just typed in. So let's do a new, and we'll verify that yeah, there's nothing here, and then we can do a star load. S is for file name, Scott, and it actually went ahead and ran it, and we can see that yeah, it is the same program, sort of. It's always my demo program, is this Scott was here thing. So anyway, that is basic. That's one of the things you can do with this. Now let me show you Forth. We'll flip this one off, and then we'll reboot again. Let me hit this, and here we've got. So I switched ROM banks. So now when I run the P command, we're running FigForth. And FigForth, if you watch my other videos, I really enjoy Forth programming. You see here it's got a pretty robust vocabulary in here, and Forth is a stack-oriented language. So 1, 2, plus dot. That will take 1 and 2, push them onto the stack. Plus will pop 2 arguments off the stack, push the result, and then dot will print the top element on the stack. So if this works, we should print out 3. Okay, did as it should. So we can also, you can define a function in Forth. I'm sure you guys are bored with me teaching you Forth every time. Let's see, print Scott function. We'll use this here. This is the print a string. Scott is running Forth. Oops. Forth. And then semicolon. Now we have a new function called print Scott. Yeah, Scott is running Forth. If I wanted one with carriage return, I would print Scott CR. We can call print Scott and then do a carriage return. There we go. Now we print Scott. Oh, I use CD instead of CR. Oh well. But print Scott CD. And then how about let's make a 2 print Scott. And here we call print Scott CD, print Scott CD, there we do, and then 2 print Scott, there, and we got our 2 Scott is running Forth printed. Anyhow, that is your basics of Forth. Okay, let's try using these multi-modules here. So we've got a sound multi-module and a speech multi-module that I have plugged in. And I've written some Forth programs to do those, so I will load those off of the compact flash. So I'm going to use actually I called it IDER. I'm going to get the directory. Now I took Stuart's routines that he wrote for BASIC and I ported them to work with Forth. So if we do IDER, we'll get a list of things, and let's do an iLoad, and we will load lamb. So the Mary Had a Little Lamb program is loaded here. You can see there's Forth words up there for it. And I need to turn off the mute. So let's try MUT. So my boards have a built-in mute feature that prevents them from emitting sound until you turn off the mute. So let's try 1 mute, and then write the 1 out to the address of mute. Let's try that, and then play melody. All right, and then let's get another directory. Now this time, this Scott was here down here. I think is this speech program. I think it'll speak out the SPO256 here. So let's do another iLoad. And then we'll do Scott was here, the list. So unmute, speak phoneme. This seems to be the speech synthesizer stuff. So let's do Scott was here. And you heard it come out there. Let me do it again. Okay, so it came out this speaker. It also, you saw some blinking on here because it actually came, if I would have had HDMI plugged in there, it would have come out over the HDMI speaker as well. Anyhow, that's a quick demo of the speech synthesizer. So you can see we've got fourth working here. Okay, let's try out the HDMI. So I'm going to plug in the HDMI. Plug it in right there into this tm990 device. Now if we go and we look right now and see what is there on HDMI, nothing is there. This is just a tm990 boot screen. It hasn't done anything. Let me go back to serial terminal. We will load basic. I'm going to push the P button and it has loaded basic, so basic is running. What is over here on HDMI now? Well, when basic loaded, it initialized the video display and it cleared the screen. But, you know, there's no output yet. We have to do one more step in order to get our video output. And that is, this thing is designed with multiple sort of display drivers. Right now we're using Unit 2, which is the serial port. We can turn on Unit 1, which is the CRT. So this is Unit 1, and now going over here onto HDMI. We can see now we have this block here, which is our cursor, and I can do 10, print, Scott was here on HDMI, 5 for I equals 1 to 20, 1, 5, next I, list. So a little bit more a guy would have to do to turn this into a standalone computer. You know, you'd have to have some kind of a keyboard, maybe use a serial keyboard, and then do a little bit of automation to automatically switch it into to turn on the HDMI in BASIC. Then you could have, you know, standalone computer. You wouldn't need a dumb terminal attached to it, which would be kind of nice. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and Sandrail stuff. Bye.